Ja, nu ska vi fortsätta och få veta mer om fosforns roll i växten. Och då säger vi välkommen till Soren Husted.
Tack.
Soren är professor i plantvetenskap och arbetar på institutionen för plant- och miljövetenskap vid Köpenhamns universitet. Och han är verksam i gränstrakten mellan agronomi och växternas grundläggande fysiologi. Och har jobbat de senaste 20 åren med mikronäringsämnen och de senaste 5 åren mycket med inriktning just på fosforn. Varsågod Søren.
Tak skal du have, Annika. Ja, og tak for invitationen til at komme til Linköping. Men ni forstår inte dansk. Og jeg forstår kun en liten svensk, so maybe we better switch to English, right? So that you can concentrate on the science part of this and maybe not trying to translate what comes out of the mouth of me. But you're welcome to ask questions in Swedish or Scandinavian or whatever you like. I think it's better that I try to speak English. This is what we do on a daily basis at the university anyway, so it should be fairly easy for you to understand what I'm trying to explain. So I've been focusing on phosphorus for 5, 6, 7 years or so. I decided that it was really time for me now to change to a subject that could really sort of change the world. It would be nice when you go on pension and you could sort of leave sort of a footprint and said, I was part of this, trying to change something. Because in Denmark, we really have to work hard on improving the way that we work with phosphorus. We have since, I think, the last 75 years or so, we have accumulated, depending on area, 1,400 kilograms of phosphorus per hectare. And still, every year, we have a surplus of approximately 15, 16 kilograms of phosphorus per hectare. So we are really way behind Sweden in getting down to this magic zero. We are really misusing phosphorus. Like many other countries in Northern Europe, we are misusing phosphorus. So we have to work with that problem. We have to come up with better fertilization strategies in order to utilize phosphorus in a decent way. We have to realize that we are in a very, very lucky position in the Northern Hemisphere that we can just, use phosphorus if we need it. We have to pay attention to the environment, of course, but on the other part of the globe, in the Southern Hemisphere, they are seriously in short of phosphorus. In many parts of Africa and Southeast Asia and so on, phosphorus is really the nutrient that is limiting plant production. So I mean, as a plant scientist, if you want to do something which is really, really meaningful, you have to focus on phosphorus. And then phosphorus is also, as a plant scientist like me, there's so many things we don't know inside the plant. And I mean, in order to improve the plant's ability to take up phosphorus, we got to understand what goes on inside the plant. So it's basically just one big buffet. As a scientist, you can work with basically anything. Whatever you do, it makes sense. At least I hope. So this is now my sort of mission here, to try to convince you that what we have been doing for the last 5, 6, 7 years makes sense. You're the judges, right? So now I'll try to explain to you why phosphorus is so fascinating seen from the plant perspective. Okay? Fosforens roll i væksten. So first, I'll give you a functional overview. What is phosphorus doing inside the plant? Then we will have to look at phosphorus and root development, because one of the take-home messages today is that phosphorus regulates root development. Phosphorus is a master variable that influences the root development in plants, and you got to understand that. Also, in the green part of the plant, phosphorus is regulating tillering. The number of branches that is being produced by wheat, barley, and so on is regulated by phosphorus. So phosphorus regulates roots, phosphorus regulates branching. And then phosphorus is a master variable in controlling carbohydrates. Phosphorus determines whether a plant is producing starch or whether it's producing sucrose. Phosphorus regulates whether the carbohydrates, they stay in the shoot or whether they are translocated to the root. So again, phosphorus is really, really a master variable here. Phosphorus drives photosynthesis. And this is why plants, they get very small if they are in short of phosphorus, because one of the first things to suffer is actually photosynthesis. So this I'll also try to show you. And this is also the key to do something new, because if we know what the role is of phosphorus in photosynthesis, we can develop new diagnostic tools that we can use to ask the plant, are you in shortage of phosphorus or no? You can't maybe not expect a clear answer, but you can measure it on the plant directly in the field. This is something that we are working on at the moment. So instead of just pouring phosphorus on the soil, we have a vision that we could try asking the plants whether they actually need phosphorus or not. And then, of course, phosphorus fertilization. The way we do it, it's not good enough. We got to come up with something new. It could be foliar fertilization. It could be more advanced ways of positioning phosphorus just below the germinating plant. So we are busy. So that's why we are moving on. And I mean, you're free to ask questions like this enthusiastic student there. Remember, there's no stupid questions. If it is a stupid question, I'll bring you home safe, I guarantee. I've been teaching for 25 years and I always manage to bring the students home safe, and I'll use the same principle here. Just feel free to ask questions if you like. Okay, so phosphorus is really sort of the energy supply of plants. It produces this magical compound, ATP, which is gasoline in plants. This is what drives metabolism. Obviously, when plants are low in phosphorus, there's a low concentration or production of ATP. This leads to a reduced growth rate. Clearly, this is the link between phosphorus, ATP, and growth rates. Then these two guys, they feed into something we call the Calvin cycle. This is where carbon dioxide is transformed into sugar. So sugar is then utilized to generate new leaves, new roots, and so on. Obviously, phosphorus is also responsible for a massive reduction in both branching and root development through this Calvin cycle. Then phosphorus is part of phosphorus lipids. These are the membranes separating cells from the neighboring cell. This is also very important. And then something that I will come back to again and again. Phosphorus is a master variable of plant hormones. So this is the key to understand. This I said in the introduction, that phosphorus regulates shoot growth and root growth via hormones. Auxin, cytokinin, and something called strigolactones, right? Okay, when plants, they become phosphorus deficient, and if they at the same time are exposed to a high light intensity, they develop something we call anthocyanosis. Anthocyanosis is the plant's sort of defense towards getting sunburned. A phosphorus deficient plant easily gets sunburned. So plants, they have developed this strategy that they can put in purple pigments above sort of the photosynthetic machinery here in order to protect the plants from getting necrotic, protecting them from dying. This is one of the really sort of unique things about a phosphorus deficient plant. If they show symptoms, it's very easy to go into the field and actually diagnose it. But this symptom will only appear if plants are at the same time exposed to high temperatures and high irradiation. So in Scandinavia, we often never see these symptoms, but if we then just move a little south to areas where it's warmer, we start to see those symptoms. But if you go out in your field trying to look for phosphorus deficiency by looking at this anthocyanosis, it's likely that you'll never find it because we don't see it very often here in Scandinavia. The way we see it in Scandinavia is basically that we see nothing. And that's a key message here, right? The most phosphorus deficiency out there, you never see it. Here we have a experiment just north of Copenhagen. This one is phosphorus deficient, heavily phosphorus deficient. This one is well supplied with phosphorus. I mean, only because I tell you so, and because you can see like a barrier here, you're able to see a difference. So one of the key messages here as well is most of the phosphorus deficiency we have out here in Sweden, Denmark, Norway, wherever, we never see it, simply because it appears as what we call a latent deficiency. Latent brist. You never see it. All right. So phosphorus is truly very complicated to work with. And one of the complicating factors about phosphorus is that it is so enormously slow. It moves very, very slow in the soil in the radial direction. So if you put a fertilizer grain here and we have the root system here, it takes very long time for phosphorus to move. On a theoretical basis, we can calculate just for phosphorus to move 1 millimeter in the soil in the radial direction. It takes 278 hours, which is 12 days. We can't really wait for that transport. And I mean, it was only 1 millimeter we were looking at. And I mean, then if you have to look at a larger distance, like 10 centimeters, and it has to move via the soil solution towards the root surface, it takes 320 years. Very, very slow. This is the key to the understanding that if we want to be successful when we fertilize with phosphorus, we gotta place fertilizer close to the root. Otherwise, it simply takes too long. So I'll show you in the end some Danish experiments that clearly highlight the importance of phosphorus placement. Typically, in Denmark at least, we put phosphorus somewhere between 4 and 7 centimeters below the seed in order for the roots to get in close contact with phosphorus pretty fast. And this about fast early on in the growing phase is very, very important. So maybe put a line under that. Plants, they need to have access to phosphorus in high concentrations within a very narrow frame of 6 weeks after germination. This is the critical window. This is where we gotta make sure that phosphorus is available. Outside that window of 6 weeks, plants will typically, at least in a Scandinavian soil where we have phosphorus added over many decades of modern agriculture, there's enough phosphorus. It's really the critical phase of those 6 weeks that are really, really important. And I'll return to that later on, but this is really one of the take-home messages here, that we gotta make sure that plants, they have access to phosphorus during this very narrow window of approximately 6 weeks. Yeah, so this about the slow mobility of phosphorus, this leads to something we call depletion zones. This has been visualized here. You can see we have a root here. This is a wheat root. You can see that we have a high concentration of phosphorus here, indicated by a green color. We have a blue color here, which indicates that there is basically no phosphorus left. So this is actually how it looks like around the root system of our cereal plants out there. That phosphorus is basically just being depleted around the roots. Outside, there's no depletion, simply because